So in this video we're going to look at solving an equation that has rational exponents in the case where the numerator of the rational exponent is an odd number. So when you're solving an equation that has a rational exponent like we have here, the rational number 3/4, the first step in the process is just to go ahead and isolate the algebraic expression that's being raised to the exponent. So if we rewrite this equation, 3 times x plus 1 to the 3/4 power minus 9 equals 15. My first step would be to add this 9 to both sides. And then I would divide both sides by the 3 that's attached to the parentheses using multiplication. So 3 divided by 3 is 1. 1 times the stuff in the parentheses is just the stuff in the parentheses, the algebraic expression that's being raised to the 3/4 power. And 24 divided by 3 is 8. And here you want to pause, and you need to look at the numerator of the rational exponent. In this case, the numerator is 3, which is an odd number, so we're in the odd number case where we know two things. Because the number's odd, we're raising something to an odd power. We know that we are not going to get a plus or minus in the solution process. And we also know that it's going to be okay for v to be a negative number. Both of those things are okay because the 3 in the numerator is an odd number. We're raising something to an odd power. When we raise a negative number to an odd power, we get a negative result. So I don't need to worry about a plus or minus, because there is no negative number that when raised to the 3rd power is going to give me a positive number. So the next step here is to raise both sides to the reciprocal of 3/4. So we're going to raise everything to the 4/3 power, raise both sides to the 4/3 power. And we do that because 3/4 times 4/3, when we multiply by reciprocals, we get 1. So this is really going to be x plus 1, the algebraic expression, to the 1st power, which means we just get x plus 1. I don't need to write it if it's to the 1st power. I don't need to write that explicitly because it just gives me one copy of that thing. And this is equal to 8 to the 4/3 power. And what we want to remember from our exponent rules, when we have 8 to the 4/3, we're really saying a couple things here. We're saying that the denominator is a 3, so that's, we have a 3 in the denominator position. 8 to the 1/3 is the cube root of 8 is another way to write that. We're asking what is the number that when you raise it to the 3rd power you're going to generate an 8. So we want the 3rd root of 8, and then the 4 is saying take that result. So if this is the 3rd root of 8, take the result of taking the 3rd root of 8 and raise it to the 4th power, or you can raise 8 to the 4th power first and then take the cube root of that. In general, that's probably not the best way to do it because raising 8 to the 4th power gives us a very large number. So in general, I think if you can do it, it's best to take the root first, in this case the cube root, which gives you a small output, right? The cube root of 8 is 2 because 2 times 2 times 2 equals 8. And then take that smaller number and raise it to the power. So if I'm walking through this step by step, x plus 1 equals, I'm going to say, hey, there's a 3 in the denominator, which is saying take the 3rd root of 8, take the 1/3 root of 8, which is this, and that's just equal to 2, and then we're going to raise that 2 to the 4's in the numerator position. And then 2 to the 4th power is 16, and then we subtract 1 from both sides and we get x equals 15. And then what we want to do once we've done that is we want to check and make sure it works in the original expression. So our check is to dump that number back into the original. So 3 times x plus 1, but x is 15. We get 15 plus 1 to the 3/4 power minus a 9 equals a 15. Add 9 to both sides. I don't even need to do that. Just leave that as a 15. We'll simplify this side. So 15 plus 1 is 16. We get 3 times 16 to the 3/4 power minus 9. The fourth root of 16, the fourth, that 4 is in the denominator. So we're saying, hey, what is the fourth root of 16? What number, when we multiply it by itself 4 times, generates a 16? And the fourth root of 16 is 2. So we get 3 times 2. I just took the fourth root of 16, and then I need to raise it to the numerator is 3 to the third power minus 9 needs to equal 15. 2 to the third power is 8. 8 times 3 is 24. And 24 minus 9 is 15. So we generated an identity, which tells us that 15 was indeed a solution. So the solution set is x is an element of the set that contains the number 15.